Hi students, today we are going to discuss about equal sets and few examples on equal sets. Let us consider two sets which are given like this. A is equal to set of 1, 2, 3 and so on, and n is the set of natural numbers. See children, now let us consider the elements in A. What elements are there? 1, 2, 3 and so on. Now what elements will be there in the set N? Now N is a set of natural numbers. So what are natural numbers? 1, 2, 3, so on. So every element of A, like 1, 2, 3 and so on, is an element of N. Then A becomes a subset to N. That we have already discussed. If every element of one set is also an element of the second one, then the first one will become a subset to the second. So here also every element of A is also an element of N. Then let me write the same thing here. Every element of A is an element of set N. So A will be a subset or equal to N. Now consider in a reverse case. What elements are there in natural number set? Yes, we already know that they are set of 1, 2, 3 and so on. Now set of 1, 2, 3 and so on, all these elements are there in set A? Yes or no? Yes. So what elements are present in natural number set? Same elements are present in A. That means, and every element of N, set N, is an element of set A. Then, so every element of set N is an element of set A. That means N is a subset or equal to A. So A is a subset or equal to N and N is subset or equal to A. Means every element of A is present in N and every element of N is there in A. So we can clearly understand that these two sets are equal. Therefore, we can write that A is equal to N. That means A and N are equal sets. So children, this is the way of finding equal sets. So when two sets can be equal, if first set is subset to the second one, at the same time second one is also subset to the first one, if and only if A, first and second sets are equal. Based on the previous example, now we are going to define equal sets. So how to define equal sets? Let's see here. Two sets A and B are said to be equal. So two sets can be equal when if every element of A or if every element in A belongs to B. If every element in A belongs to B, then it becomes A subset or equal to B. And every element in B belongs to A, then B becomes a subset or equal to A. Then these two sets are said to be equal. Now same thing we can write like this. A is subset or equal to B and B is subset or equal to A if and only if A is equal to B. Now this symbol is two-way implication, generally read as if and only if and written as if. Okay. Now what is the condition? A must become subset or equal to B. At the same time, B is also subset or equal to A. Then automatically A and B becomes equal. Or if two sets are equal, then A is subset to B and B is subset to A. So we have understood the concept of equal sets. Now let us try some examples based on equal sets. Here is one example. If A is equal to set of PQR and B is equal to set of QPR. So two sets are given, A and B. Then check whether A is equal to B or not. Now let me write first given sets. A is equal to set of P, Q, R. B is equal to set of Q, P, R. Now check P is in A. Is it an element of B? Yes. Q is in A. Is it an element of B also? Yes. R is in A. Is it an element of B? Yes. That means every element in A belongs to B. So let me write like this. Here, every element in A belongs to B. Therefore, if every element in A belongs to B, that means A is subset or equal to B. This is one relation that we got. Now let us check with respect to B. Is every element of B belongs to A? Q, P, R. Absolutely. So here every element in B belongs to A. Therefore, every element in B belongs to A. Therefore, B is subset or equal to A. Relation 2. So, from about two relations, from 1 and 2, we can say, so if A is subset to B and B is subset to A, then that A is equal to B. Here is a short and interesting question. Let's see. Consider the sets A is equal to set of PQRS and B is equal to set of 1, 2, 3, 4. Are they equal? So first, let me write what are the sets given. Given A is equal to set of P, Q, R, S and B is equal to set of 1, 2, 3, 4. Now, children, just observe the two sets and their elements. Are they equal? No. Why? Why are they not equal? Yes, simply because A and B sets do not contain same elements. Do they have same elements? Not even a single element is same. So we can write here A, B sets do not contain same elements. Since they do not contain same elements, A is not equal to B. Let us see example number 10. Let A be the set of prime numbers smaller than 6. So A is a set of prime numbers which are smaller than 6, and then B be the set of prime factors of number 30. Check if A and B are equal. Children, here sets A and B are not given in roster forms. Let us write them in roster form. Then we can able to compare both the sets. A is equal to set of prime numbers smaller than 6. Children, what are prime numbers? Yes. So prime numbers are the numbers which have only two factors, that is 1 and itself. A is equal to prime numbers which are smaller than 6. So what are the prime numbers which are smaller than 6? Yes, 2, 3 and 5. So next prime number is 7, but that is not smaller than 6. So up to 5 only is a set. Now these are the prime numbers 2, 3, 5. Prime numbers smaller than 6. Now B is equal to set of prime factors of 30. So what are the prime factors of 30? Let me find here. Prime factorization. 2 is the first prime number in 30. How many 2's will be there in 30? Yes, 2 15s. Now 15 will go in 3 table, 3 5's, and 5 is a prime number, so we can stop. Now what are the prime factors? 2, 3 and 5 are the prime factors for 30. So B is equal to 2, 3, 5. Now compare both the sets. Every element in A is an element in B. Every element in B belongs to A. So A is subset to B and B is subset to A. Here A is subset or equal to B and B is subset or equal to A. Therefore A is equal to B. Now example 11. Show that the sets C and B are equal. So two sets, we have to show them that they are equal. Where C is equal to set of X such that X is a letter in the word assassination. And B is equal to set of X such that X is a letter in the word station. Children, what forms are these two sets are in? Yes, they are set builder forms. Now, to compare two sets, it is easier if they are in roster forms. So let us write these two sets in their roster forms so that we can compare them. Okay? Now, roster forms of given sets. C is equal to set of X such that X is a letter. So we have to write the letters where in the word assassination. Now in this word assassination, what letters are there? Those are the elements. Now let's see here. What is the letter? A. Next S. Next yes, already written. It should not be repeated. A is already there. Yes is already there. Yes is already there. I. Next N. A is written. T. I is written. O. N is already written. A, S, I, N, T, O are the letters in the word assassination. Now let me write the roster form for the set B. Now what is set B? X such that X is a letter in the word station. So in that word, what letters are there? Let me write here or list the elements. S, T, A, T repeated, I, O, N. Yes. Now compare these two elements. A is in C. Does it belongs to B? Yes. Yes is in C. Does it belongs to B? Yes. I N T O. Now every element of C belongs to B. So C is a subset to B. Here C is subset or equal to B. Now reverse, we check. S T A I O N. So every element of B is also belongs to C. That means B is subset or equal to C. So C is subset to B and B is subset to C. That implies C is equal to B. That means these two sets are equal because they contain same elements. Here is one more example. It is like this. Consider the sets phi. Children, we know what is phi? It is null set or an empty set. Means a set with no elements. And A set of 1, 3, B set of 1, 5, 9, C set of 1, 3, 5, 7, 9. Okay. So phi, A, B and C are the sets given. And insert the symbol subset. So this symbol is called subset or not a subset. So subset or not subset. A proper symbol we have to insert in the blanks between each of the following pairs of sets. So here are 4 pairs of sets and we have to insert a proper symbol, and let us even write the justification. Means why are we putting the symbol in between? Okay. Now let's see here. Phi dash B. What is phi? Phi is an empty set. Dash B. Either subset or not subset we have to put. So irrespective of what elements are there in B, let's see, phi is an empty set and we know one rule that null set is subset to every set. See, to become not a subset, there must be at least one element in the set which is not there in the other. Can you find any element in null set which is not there in B? No, we cannot. Why? Because there are no elements in null set. So automatically a null set becomes subset to every set. So that's why we have to write the symbol subset. Why? Because null set is subset to every set. Now A dash B. Now what elements are there in A and compared to B? A contains 1, 3 and B contains 1, 5, 9. Now let's check. 1 belongs to A, 1 belongs to B. Great. 3 belongs to A. No. 3 does not belong to B. So there is an element 3 in A which is not there in B. So can A be a subset to B? No way, because to become subset, every element must be there in the other one. But every element is not there. 3 belongs to A, but 3 does not belongs to B. So A is not a subset to B. A is not a subset to B because 3 belongs to A, but 3 does not belongs to B. Now let's go for the third one. A and C. A set of 1, 3. C set of 1, 3, 5, 7, 9. Now compare the elements of A, whether they are there in C or not. Let us check. 1 belongs to A. Yes, 1 belongs to C. 3 belongs to A. Yes, 3 belongs to C. That means every element of A are there in C. That means A is a subset to C. So let me write the same thing. A is subset to C because every element of A is also an element of C. That's why A is subset to C. Now the last pair of sets, B and C. So here are the sets B and C. B is set of 1, 5, 9. C is set of 1, 3, 5, 7, 9. Now let's check whether every element of B is also there in C. 1, yes. 5, of course. 9, great. So all the three elements of B are there in C. That means every element of B is an element of C. So B is a subset to C. Why? Because same reason, every element of B is also an element of C. So children, we have kept the proper appropriate symbol and we have even given the reason for the step. Now let us solve the problems in exercise 2.3 of the chapter sets. Here is the first question. Which of the following sets are equal? So here three sets are given, A, B and C, and are they equal or not? Let us check. A is equal to set of X such that X is a letter in the word follow, and B is a set of X such that X is a letter in the word flow. C is a set where X is a letter in the word wolf. Now here all the three sets are about the letters in different words. Now let me write the same sets in roster form so that we can compare them easily. Now let's see here. Given sets in roster form. A is equal to set of a letter in the word follow. So what letters are there in the word follow? We have to write or we have to list. But while listing the elements or letters, we should be careful that no element is repeated. Why it should not be repeated? Because the elements of a set are distinct. Okay, now let's write F, the letter in the word follow, F, then O, L, L is already written, O is already written, W. So 1, 2, 3, 4. So there are 4 letters in the word. Now let me write set B. B is equal to set of X such that X is a letter in the word flow. So what letters are there in that word? F, L, O, W. Great. Now the last one. C is equal to set of X is a letter in the word wolf. So what letters are there? W, O, L, F. Great. Now let's see here. Compare these three sets. F is an element of A, it is an element of B, it is an element of C. Great. O is there in A, B and C. L is in A, L is in B and L is in C. W is in A, B and C. That means all the elements are same. 1, 2, 3, 4. So every set is having 4 elements and all the 4 elements are same. So all these 3 sets contain same elements. Here the given sets contain same elements. Therefore A is equal to B is equal to C. That means all the 3 sets are equal sets. Now the second question from the exercise. Consider the following sets and fill up the blanks with equal to or not equal to. So we have to fill the blanks with either equal to symbol or not equal to symbol, so as to make the statements true. So to make the statements true, we have to put the right or appropriate symbol, whether it is equal or not equal. Now let's see what sets are given. A is set of 1, 2, 3. B is the set, the first three natural numbers. Children, what are the first three natural numbers? Yes, 1, 2 and 3. That means these two are equal. C is equal to A, B, C, D, and D is equal to set of D, C, A, B. Here 4 letters and 4 letters. Yes, A, B, C, D, A, B, C, D. That means these two are also equal. E is equal to set of A, E, I, O, U. What are the letters A, E, I, O, U? Yes, they are vowels in English alphabet. Now F is equal to set of vowels in English alphabet. Yes, these are the vowels in English alphabet. That means E and F are also equal. Now let's put the appropriate symbol in the given blanks. Now first one, A dash B. A and B. What symbol must be there? A set of 1, 2, 3. B set of first three natural numbers. Yes, first three natural numbers are 1, 2, 3 only. That means both are having the same elements. So the symbol must be obviously equal to. So A is equal to B as they have same elements in both. Now A dash E. What is A? Set of 1, 2, 3. What is E? Set of A, E, I, O, U. Now these two sets, do they have same elements, children? No. So what must be the symbol? Not equal to. Great. Now third one, C and D. Compare the sets C, D. C set of A, B, C, D, the first 4 letters in English alphabet. D set of D, C, A, B. So A, B, C, D. All the elements are same in both C and D. So obviously C is equal to D. Now let's see D and F. D, F. What are the elements in D? D, C, A, B. What are the elements in F? Vowels in English alphabet. So D, C, A, B, are they vowels in English alphabet? No, they are not vowels. That means these two sets are not equal. Now F and A. F is set of vowels. A is set of 1, 2, 3. Are they equal? No, clearly not. And D, E. D, E. D contains D, C, A, B, and E contains A, E, I, O, U. Are they equal, children? No, because D contains D, which is not there in E. So they are not equal. So D and E are not equal. Now the last one, seventh one, F dash B. F set of vowels in English alphabet dash B. First three natural numbers. Now F is having the elements as vowels, whereas B elements are numbers. They are not at all equal. So F and B are also not equal. Here is the third question, and it is like this. In each of the following, state whether A is equal to B or not. So whether A and B are equal or not, we have to state. Now the first one is like this. A is equal to set of A, B, C, D, and B is equal to set of D, C, A, B. We have seen such kind of sets in the previous problem too. Now, how many elements are there? 1, 2, 3, 4. 1, 2, 3, 4. So 4, 4 in each of the sets. And A, B, C, and D. So every element of A is an element of B. Every element of B is an element of A. A is a subset to B. B is subset to A. That means these two sets are equal as they have same elements in them. So A is equal to B. Now see the second one. A is equal to set of 4, 8, 12, 16. And B is a set of 8, 4, 16, 18. Now let's check. A and B, are they equal? 4 belongs to A and B. 8 belongs to both A and B. 12 belongs to A. No, not in B. So 12 belongs to A, but 12 does not belongs to B. Similarly, 16 belongs to A, 16 does not belongs to B. Or 18 belongs to B, but not in A. They do not have same elements in them. So obviously, they are not equal sets. So we have to write A is not equal to B. Let's see the third one. A is equal to set of 2, 4, 6, 8 and 10. Now B is equal to set of x such that x is positive even integer where x is less than 10. So less than 10 positive even integers, we have to list them out because this is in set builder form. Let me write in roster form so that it will become easier to compare the sets. So positive even integers less than 10. What are the even integers? Positive even integers which are less than 10? Yes, they are 2, 4, 6, 8. And they are less than 10. So these are the elements. Check. 2, 4, 6, 8. Of course these elements are there, but 10 belongs to A and 10 does not belongs to B. Why? Because the element is less than 10 is the condition. Okay. Since 10 belongs to A and 10 does not belongs to B. So these do not have the same elements. So automatically A is not equal to B. Let's see the fourth one. A is equal to set of x such that x is a multiple of 10. What are multiples of 10? Let me list here. 10 ones are 10, 10 twos are 20, 10 threes are 30 and so on. These are multiples of 10. Now what is set B? 10, 15, 20, 25, 30. Now 10, 20, 30, every element of set A are there in 10, 20, 30 in B. But every element of B are not there in A because 15, 25 are there in A? No. So I can write like this. 15 or 25 they belong to B, but 15, 25 does not belongs to A. Since they do not contain the same elements, they are not equal sets. Yes, A is not equal to B. In this question, he is asking us to state the reasons. So here he has given 4 statements where the sets are not equal and we have to say why are they not equal. Okay, we'll start with the first one. Set of 1, 2, 3 so on 10. So these are all natural numbers up to 10. Now here this set is not equal to set of x such that x belongs to n, means natural numbers only, but 1 less than x less than 10. That means the elements in it are in between 1 and 10. X is greater than 1 and x is less than 10. Greater than 1 means 2, 4 so on up to 9 only. But whereas the first set contains 1 and 10 also, second set do not. That's why they are not equal. So first set is 1, 2, 3 so on up to 10. That's why they are obviously not equal. Now we'll go for the second. Here is the set 2, 4, 6, 8, 10. These are all even numbers. Now x such that x is equal to 2n plus 1 and x is natural number. See, the condition 2n plus 1 means it is an odd number because even numbers will be in the form of 2n because they are divisible by 2 and odd numbers do not they are not divisible by 2 and they leave remainder 1. So here 2n plus 1 is odd, but elements 2, 4, 6 are even. So 2n plus 1 is actually odd, but the first set contains even. Even numbers and odd numbers are not equal sets. Now, third one. 5, 15, 30, 45. Okay. Next, set of x such that x is a multiple of 15. See, in this, it is saying that the set contains the elements which are multiples of 15. Is 5 a multiple of 15? No way. 5 is not a multiple of 15. That's why they are not equal. Next, set of 2, 3, 5, 7, 9. And here x such that x is a prime number. 2, yes, it is a prime number. 3 is a prime number. 5 is a prime number. 7 is a prime number. 9, no. 9 is not a prime number. It is a composite number. 9 is not prime. That's the reason this statement is given. And the last question from this exercise is like this. List all the subsets of the following sets. So we have to list all the subsets. Children, how many subsets will be there to a set? Yes, the number of subsets of a set is given by 2 power n, where n is the cardinal number, means the number of elements in it. Let's see here the first one. B is equal to set of P comma Q. Here n, number of elements 1, 2. 2 elements are there. So number of subsets will be 2 power n, that is 2 power 2, that is 4. So 4 subsets will be there. Let me list all the subsets. So first thing that we have to keep in mind, that null set is a subset to every set. That is one. And next, every set is subset to itself. So these two things you have to keep in mind while you are listing the subsets. So first one is, so let me write here subsets. First one is empty set. Next, set of single elements, let me write set of P and set of Q. Next, 2 elements, that means both set of P comma Q. Children, you may write set of PQ or QP, but both are same. So how many subsets are there? Let me count here. 1, 2, 3, 4. So how many subsets? 4. Now we'll do the second one. Second one is like this. C is equal to set of X, Y and Z. So there are, how many elements are there in set C? Yes, 3 elements are there. So number of elements in set C is 3. Then number of subsets is equal to 2 power n, that is 2 power 3. So 2 power 3, how much children 2 power 3? Yes, 8. 2, 2 and 2. 2 to the 4, 4 to the 8. So 8 subsets will be there, and the first subset is a null set and the last subset is itself, because an empty set is subset to every set and every set is subset to itself. So let me list all the subsets. First one is an empty set. Next, single element sets, let me make set of X and set of Y, set of Z. Okay, now let me make two elements sets. Set of XY, good, with X, XZ. Set of XZ, and with Y, YZ. Set of YZ. Now let me make the 3 elements set, that is X, Y, Z itself. So let me count how many subsets came. 1, 2, 3, 4, 5, 6, 7 and 8. So number of subsets is 8. Now the third one is D is equal to set of A, B, C, D. See here, what is the cardinal number, the number of elements in this set? 1, 2, 3, 4. There are 4 elements in this set. So number of subsets is 2 power n. Number of subsets is given by 2 power n, which is equal to 2 power 4, that is 16. So there are 16 subsets for this one. So what are they? The first one is obviously an empty set. Second one, will start with single turn sets, means set of A, set of B, set of C, set of D. Then we'll make 2 element sets, means set of AB, set of AC, set of AD, with A over, now with B, set of BC, set of BD, now with C, set of CD. Okay, and with D you cannot make 2 elements. Next, 3 element sets. Let us make ABC and ABD. Next, ACD. Next, with B, BCD. That's it. Now all the 4 elements, set of A, B, C, D. Yes. Now let me count whether the number of subsets is equal to 16 or not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So there are 16 subsets because the number of elements is 4. Now let me do the fourth one. E is equal to set of 1, 4, 9 and 16. Similar like this only, n is equal to 4 elements and number of subsets are 16. Let me directly write the subsets here. Right. First subset is obviously a null set or an empty set, or you can even write an empty set like this. Next we'll write 1 element sets, set of 1, set of 4, set of 9, set of 16. Okay, now 2 element sets, set of 1, 4, set of 1, 9, set of 1, 16, set of 4, 9, set of 4, 16. Now set of 9, 16. Now 16 is only 1 element, we need 2 elements. Now with 3 elements, let me make sets. Set of 1, 4, 9, set of 1, 4, 16. 1, 4, 9, 1, 4, 16. Next, set of 4, 9, 16. 1, 4, 9, 1, 4, 16. Then set of 1, 9, 16. And yes, all the elements, set of 1, 4, 9, 16. So how many are the subsets? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. Absolutely. Since the number of elements are 4, 2 power 4 is 16. So 16 subsets will be there in this.